Okay, my name is Venkata Prasad. Okay, today is the first demo session for the SQL Server 2022. Okay, so here you learn 2022 version SQL Server. Let me write here SQL Server 2022. Okay, let's start with the fundamentals. Okay, fundamentals of database systems. Okay, fundamentals of database systems. Okay, under these fundamentals, what we are going to learn is the first one is data and information. Okay, data and information. Next one is database. Third one, DBMS. Okay, database management system. Database management system. Okay, RDBMS, a relational management system, relational database relational database management system, RDBMS. Okay, now start with data. Okay, data. What is data? Data is nothing but raw facts. Okay, that have no context. Okay, or meaning by itself. Okay, itself. Data is nothing but raw facts that have no context or meaning by itself. Okay, example. Let us take a list of numbers. Okay. Numbers 85, 72, 90. Okay, 65, something, 78. Okay, these are the list of numbers. Okay, so these are just numbers. Okay, they may be roll numbers or marks or something else. Okay, we don't have any context here. Okay, that could be a roll number or room numbers or marks, like that. So there is no meaning. It is just a list of numbers. Okay, now here let me give one more example. This is on an example. One more example is Rahul 25, New Delhi. Rahul 25, New Delhi. Okay, so it is just a actually what it is, pieces of raw information. That's it. It is not telling anything. There is no context here also. Okay, and if you see, when it is useful, data becomes useful only when it is processed and organized, or if it is given context. Okay, data becomes useful only when it is processed. Processed in the sense, processing data means refining and converting it into something that we can understand and use it. Okay, that means processing converts raw data into usable result. Okay, a meaningful information we get. Okay, and it is organized. That means it is data. If it is organized, then it is called as this is called as information. We call it as information. Okay, data, it is just raw fact. Okay, if it is organized or processed, something we can understand that. That means converting raw data into a usable result, then it becomes information. Okay, now the same statement, the above one, Rahul 25 New Delhi. Okay, let me write like this. Rahul is a student. Rahul is a student. He is 25 years old and lives in New Delhi. Right? New Delhi. Now see this, it is meaningful. If you see the first one, Rahul 25 New Delhi, it is not giving any kind of information. Okay, so we gave a structure here. Okay, we processed it and we gave a structure here. Okay, Rahul is a student. He is 25 years old and lives in New Delhi. So it is meaningful. That means, so information is nothing. Information is nothing but processed data that has meaning, and it is useful for decision making. Okay, so information is nothing but processed data that has meaning and it is useful for decision making. That means it is organized, structured, and interpreted. Okay, okay. You just see the first example, list of numbers are there. What does it mean? They are just numbers. There is no meaning at all. Okay, now the same list of numbers, let me take here. Okay, the same list of numbers. Okay, if I create like this, okay, that means just I am arranging them in structured format. Okay, here you see it is a structured format. Okay, it is a structured format. What did I mention here? Roll number, name, subject, marks. Okay, roll number, name, subject, marks. Okay, here you just take 85. Okay, 85. Next 72, 90. Now you see these are the roll numbers. Here. I have taken it as roll number. Okay, and name Kumar Gautam Ramesh I have given. Subject maths, marks 85, 72. Okay, 85, 72, 90. Okay, sorry, 101 here. 101. Let them like that. 101, 102. These are the roll numbers. Okay, 103. Okay, here are the marks. Here I consider them as marks 85, 72, 90. Okay, it is in a structured format. Okay, so I arranged the data in a structured format that makes it more useful, okay. So here if we ask a question, who scored highest marks in maths, okay, we can say Ramesh, he got the highest score in mathematics, okay. Mathematics, he got the highest score, that we can say by seeing the data, okay. And also you can calculate the average score for all the students also, okay, if it is asked in another scenario or another context, okay. So we can by seeing the data we can tell whatever the things we need, okay. So this is roll number 1 Kumar, his name is Kumar, maths subject is maths, 85 marks, okay, he got in mathematics. In this way we get the meaningful information, okay. You just see the previous one, list of numbers, it doesn't mean anything, they are just meaning of what is this list of numbers, they are just numbers, that's it, okay, they are just numbers. Now we arrange them in tabular format, okay, that is called information. Now data, we have many types of data are available, now just see the main types of data, let us see that main types of data. The first one is structured data. And unstructured data, second, and third one is semi-structured data. Okay, what are they? First one, structured data. Let us see. Structured data. What does it mean? Data stored in a fixed format, okay, using predefined rules. That means schema, we call it as schema, predefined rules, schema, okay. That means here we are giving a fixed format, that is called structured data. That means data organized into rows and columns, okay. That means well organized in tables, so tabular format, okay. What is the advantage here? It is easy to search and analysis or analyze, easy to search and analyze, okay, This is structured data stored in fixed format, rows and columns, we store them in rows and columns, okay. Example, rows and columns in a employee table, rows and columns in a employee table, okay. The next one is unstructured data. The first one is fixed format, right? Here in unstructured format, data with no predefined format. That means this data has no fixed format. Okay, no fixed format. Data, it doesn't have fixed format. That is called unstructured data. Okay, which contains rich information. Okay, Okay, but difficult to organize and analyze. Okay, examples, emails, okay, videos, images, okay, PDF files, social media posts, etc. Okay, these are unstructured data. It has no fixed format. The first one is it has fixed format, and data will be organized in tabular format, rows and columns. That is called structured data. That is called structured data. Unstructured, there is no fixed format. Now see the third one, semi-structured data. Semi-structured data. Semi-structured data. Semi-structured data. Semi-structured data. See, data that is, or data that is not fully structured, okay, like tables, but still has some organized tags or markers. Tags or markers. What are they? Here, semi-structured in the sense semi-structured, that means not fully structured. Okay, not fully structured like tables, but still has some organized tags. Okay, what are they? Let us see the examples. XML we have. Okay, JSON we have. Okay, log files, logs we have. Okay, API data we have. Okay, emails metadata we have. Metadata, and also that means no SQL data. The first one is SQL data. Here SQL, this is SQL. Okay, data will be stored in rows and columns. Here no SQL data. Okay, like MongoDB. Okay, it's a database management system. Okay, here XML JSON. Do you have any idea about XML JSON? Do you have any idea about XML JSON? Okay, XML in the sense, they are just tags. Okay, they are just tags. Okay, let me write here. Okay, example for XML. Suppose I want to store students information. Let us see how to write that. Student. Okay, student. Open tag, close tag. It is a rule. Open tag, close tag. If you open the tag, you have to close the tag. Okay, student. Name. Venkata. Okay. Close the name tag. Next, age is something 40. Okay, is close the tag. Open tag, close tag. Course SQL server. Close the tag. Course, or let me write like this. Course. Okay, course. Okay, this is the format, XML format. These are the XML tags. Here we are just written, we have just written XML tags here. It is showing student information. This is one student information. Okay, name tag. Okay, age tag, course tag. For everything we use tags: open, close, open tag, close tag. That is XML. That we call it as XML. Okay, it is very structured and supports metadata. Okay, and actually in legacy systems, old systems, we used to work with the XML. Okay, now that is replaced with JSON, JavaScript object notation. Okay, JavaScript object notation. In JSON also we can write the same information. Okay, XML in the sense extensible markup language. extensible markup language. Here JavaScript object notation, JSON in the sense. Okay, now same information, just write in JSON format. Let us take a student only. Example. Let me write like this. JSON example. Actually, in JSON, how we write is we open the curly braces starting, okay, and we have to end with the curly braces like this, okay. In that we write like this: student, 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 okay, student, okay. Now here square brackets we use, square brackets. In this we write our data. Okay, in this we write our data. Let me write the data here. Okay. Again, curly braces for individual data. It is okay. Name, Venkat. Okay. Is okay. Something 40. Okay. Course. SQL server. Okay. Now I want to have one more record. Just copy paste that one. Copy paste. Name. You change this name here. Something Raju. Okay. Name. Okay. 30. SQL server or .NET, something else. Okay. So in this way we write the information. This is a JSON format, and here this is XML format. Okay, these are the examples for semi-structured data. These are the examples for semi-structured data. Okay, and also here I mentioned MongoDB. It is a NoSQL data. NoSQL data in the sense, NoSQL stands for not only SQL. Okay, it's a type of database that uses a flexible formats. Okay, flexible formats. Okay, flexible formats. Okay, no SQL. That is no SQL. Okay, now till now what we have seen is we started with fundamentals, right? In the fundamentals, first one is data and information. Data in the sense raw facts that we understood. Okay, if it is organized, that means if it is processed, okay, that means data will be in a meaningful format, that is called information. Now types of main types of data also we have seen: structured data, unstructured data, semi-structured data. We covered that. Okay, now the second one is, what is the second one? Database. Let us see that what is a database. Okay, let us try to understand that. Okay, what is a database? A database is an organized collection of data. A database is an organized collection of data. Okay, or database in the sense, a database is a digital storage system where data is organized in a structured way, so it can be easily accessed, managed, updated, okay, and updated and retrieved. Okay, a database is a digital storage system where data is organized in a structured way, so it can be easily accessed, managed, updated, and retrieved. Okay, that is called database. Database is nothing but organized collection of data. Data we have seen. Now, organized collection of data, that is database. That is database. Okay. Now, why do we need a database? Why do we need a database? Let me copy this here. These are the benefits of having, let me, where is this one? Why do we need a database? We need database to store data and organizing data. To store data and organizing data. Okay, reduce duplication, maintain accuracy, multi-user access, and we can provide security, and we can take the backup, and whenever we have problem with the database, we can recover that. Recovery we can do. And also we need it for fast search and reports. These are the advantages of database, having database. Okay, these are the advantages of having a database. Okay, now see, actually, earlier, many organizations, or if you take banks, if you take hospitals, universities, colleges, schools, the employees, they used to maintain data, everything in the books itself, accounts and ledger books in banks. Okay, and if you take hospitals, patients history books. Okay, and they are just manually, they used to manage everything. Okay, manually they used to maintain the data. For everything they used to maintain in manual way. Okay, so they used to maintain books. So this is nothing but database, right? Later they started using Excel sheets. Okay, later, after that they started using Windows application softwares, Windows application softwares or standalone applications. Okay, um, after that, with the technology revolution, they started using web enabled applications. That means internet applications, web applications. Okay, so same information maintained in different ways. Everything is a database. Okay, now let us see the types of databases. Let us see the types of databases. Let me write here. Types of databases. How many types are there? Let us see that. These are the types of databases. Okay, databases are categorized based on how they store. And organize and manage the data. Okay, they are categorized. Databases are categorized based on how they store, okay, organize and manage data. Okay, let us see one by one. Relational databases. The first one is relational databases. No SQL databases, hierarchical databases, network databases, object-oriented databases, time series databases, multi-model databases, cloud databases, and in-memory databases. We have number of databases. Okay, number of databases. Now, see the first one, relational databases. Relational databases. Okay, here data will be stored in tabular format. That means stores data in tables. That means rows and columns. Okay, and we use a query language to get the information to operate on the database. Okay, that is called SQL here. We use SQL here. Okay, and also let me write. We use a query language called SQL, structured query language. Okay. So next one is it enforces relationships. Okay, relationships. Okay, using primary and foreign keys. Okay. Examples, if you take SQL Server, okay, Oracle, best examples, Oracle, MySQL, and also PostgreSQL, okay, PostgreSQL, okay, PostgreSQL also an example for relational data. Our concern is with relational database only, okay. We are just seeing the other databases, what types of databases are available. Just we are trying to cover that. Okay, no SQL database. And then the next one is no SQL databases. Okay, here no SQL. Let me write no SQL. Wait, no SQL databases are used for semi-structured or unstructured data. Okay, NoSQL databases are used for semi-structured or unstructured data. Okay, it has many types here. There is no fixed type. It has a flexibility. Okay, according to the requirement, we can store that type. Okay, suppose I have document oriented. Okay, I can store that. And key value stores also there. Column oriented graphs I want to store, that we can store in as NoSQL databases. Okay, it depends upon the requirement. Okay, now here the examples are we can say actually MongoDB. Okay, MongoDB and Cassandra. Okay, Cassandra. Next Neo4j. Okay, like that. Okay, NoSQL databases. Next one is hierarchical databases. Here data will be linked, or they used to maintain relationship between the data. It is like a tree like structure. That means parent child relationship. Okay, okay, so it was a long ago actually. So in legacy systems they used to work with the hierarchical databases. Okay, examples IBM information management system. It's an example for hierarchical databases. Okay, the next one is network databases. Okay, here it allows many to many relationships. Okay, so here the example is Codacil DB. Okay, it uses graph structures for records and links, actually network databases for graphs and all. Okay, the next one is object oriented databases. Okay, it allows or it stores data in the form of objects. Data will be stored in the form of objects. Okay, so here Object in the sense, if you have aware of OOPS concepts, what we have, inheritance and encapsulation, like that, right? So it supports all these features. Okay, examples, object DB, it's a database. Okay, DB for O. Okay, objects we can store in the form of data in the form of objects. Next one is time series database. Okay, actually it is optimized for storing and querying timestamped data. Okay, actually it is for financial data. Okay, the examples are influx db. Okay, or we have time scale db also. Okay, next one is multimodal databases. Okay, multimodal in the sense multiple types, different types. It supports multiple data models, documents we can store. Okay, and graphs we can store. Okay, and also next one is key value pairs, we can store like that. Key values we can store. Okay, key values. The best example is Cosmos Azure Cosmos DB. Okay, multimodal database. Okay. Next one is cloud databases. Actually, earlier companies, they used to manage their servers in the organization's premises. Later, they started moving to cloud technology, clouds. So long ago, cloud technology started, and slowly companies also changed. So they started moving their databases to cloud. Okay, so that means hosted on cloud platforms. Okay, it can be SQL or no SQL. Okay, and examples, if you see Azure SQL. Okay, Amazon RDS, that means relational database services. Okay, they are the examples for cloud databases. Next, in-memory databases. In-memory database in the sense data stored in RAM. Okay, for high speed access. Okay, examples Redis. Okay, SAP HANA, they are the examples. Okay, now so here we have seen database, what is a database, and types of databases also we covered. Okay, so the second one is the database. The third one is database management system. Data, we have seen database, we already seen. Okay, now the next one is DBMS, database management system. Database management system. The next one is database management system. Okay, so actually a DBMS, let me write, a DBMS is a software that helps us to store or helps us to create, store, okay, manage and retrieve data from a database. Okay, from a database. What is a database? Database is a collection of data, organized collection of data. Okay, database is an organized collection of data, and to manage these databases we need a software, and that software is, we call it as a database management system. Okay, database management system. The name itself saying it is designed to manage the databases. Okay, it's an interface to the databases. Okay, databases. Now, that means through this database management system, we can communicate with the database. Okay, through this database management system, we can communicate with the database or operate on database. We can communicate with the database or databases. Okay, databases or operate on databases. Okay, it's an interface to the database. Okay, next, exactly. See, this is a software. Good. So with this software, by using this software, what we can do, we can create, store, manage, retrieve data, right? Okay, let us see. Let us see a little bit deeper. Okay, let me what we can do with the database management system. What we can do with the database management system. Okay, here we can store the data. The first one is we can store the data. Okay, we can insert new data, we can update existing data. Okay, and we can delete the data. By using this software, we can do all these things. Okay, we can query data, we can organize the data. Okay, we can organize the data, and we can control, we can give, or we can control access and security. Access and providing security, we can provide security, right? So control access and security, backup and recovery we can do, and maintain data accuracy. Okay, that means we use some rules. Actually, we use some rules, we call them as constraints to ensure valid and correct data, to ensure valid and correct data. Okay, and also we can generate reports, okay, by using DBMS, database management system. Okay, these are the features, DBMS features. Okay, now let us see how the things change. Let us try to understand. Till now we have seen data and database management system. Okay, now actually different types of databases are designed and introduced to accommodate the different types of data, right? Different types of data. Okay, databases are introduced or designed to accommodate the different types of data. Okay, now just see. Now we have seen data, how many types of data available. The main types we have seen here: structured data, we have seen unstructured data, semi-structured data. Okay, now see here, let me show you the PPT here. Okay, see here, data we have. What type of data we have? Structured data we have. Okay, let me take this one. Okay, see, data we have. Okay, structured data, unstructured data, semi-structured data. Structured data, unstructured data, semi-structured data. Okay, suppose the data type is structured data type. The data type is structured data type. That means rows and columns. Okay, I already explained you that data will be stored in rows and columns. See the tabular format here. Data will be stored like this. If you take structured data, it is well organized data in tables. See, rows and columns. It is called structured data. Okay, so it is in tabular format. Okay, and tabular format, here you see rows and columns. That means here we have a relations. Okay, rows and columns. These are the rows. Okay, and columns we have. Okay, let me. Columns we have. That means we have relations also. A relation in the sense establishing a logical connection. Okay, then since it is maintaining a structured data, that database becomes relational database. That becomes relational database. Let me show you that here. Where it is. Let me show you that. First you see this one, structured data. So data will be stored in tabular format. Unstructured data means data has no fixed format. That means for images, audio files, okay, videos, documents, we use unstructured data. And semi-structured in the sense XML. I explained you that JSON format. Okay, API data, emails data, metadata, like that. Okay, these are the data types. Okay, data types. Now let us go to this. Let me click here. Okay, relational database management system. Wait. Okay, types of databases. Okay, DBMS, database management system. Now here, if you see, here we have structured data. Here you see the right side one, relational. Here type of the data is structured data. That means rows and columns. That means it is a relational database. Okay, relational database which is accommodating structured data. Okay, and to manage this type of databases, we have a software called RDBMS, Relational Database Management System. It's a software, okay, database management system that we call it as Relational Database Management System, because it is managing relational database. Since it is managing relational database, okay, it becomes a relational database management system. Okay, now since this relational database management system is managing relational databases, to communicate with these relational databases, we use a structured query language. Okay, a query language called structured query language, because it is structured data. Okay, it maintains structured data. That's why we use a query language called structured query language, SQL. We call it as SQL, to communicate with the database. Okay, to communicate with the database through relational database management system. In order to communicate with the relational database, we use a query language called structured query language. Okay, structured query language. And the next one, if you see, next one is here structured data, right? The next one is see the next one here. See here type of the data is unstructured. That means no fixed format, and semi-structured. Okay, that means not in rows and columns, non-relational database. Here we are storing the information, unstructured data and semi-structured data here. That's why this database becomes no SQL database. And to manage this type of databases, we have a database management system, a software. We call it as NoSQL DBMS, NoSQL Database Management System. Through this, we can manage these type of databases. What type of databases? Unstructured data or semi-structured data we can manage. That means no SQL database, no SQL database. And through this no SQL DBMS, to communicate with the databases which accommodates no that means unstructured data and semi-structured data, we use a language here. Actually, there is no universal language here. It depends upon the companies what they design. Here, MongoDB is a company which designed its own language. We call it as Mongo query language to communicate with this database. And also another company, Cassandra designed its own query language, Cassandra query language, to communicate with this database because it is no SQL database. Okay, so companies, they designed their own languages to communicate with the no SQL databases. Just see here, MongoDB, Mongo query language. Okay, Cassandra query language. Okay. They designed their own languages. Okay, now the next one is here. Actually, for the first one, relational databases, we have SQL Server, Oracle are the examples. For the next one, NoSQL, MongoDB and Cassandra are the examples. Okay, now let us see the evolution of DBMSs. Okay, evolution of database management systems. Okay, now just see. Let me copy and paste here. Okay, evolution of database management systems. Okay, actually, in 1960s, flat file system. Okay, so at that time they used to store data in plain text. That means .txt formats, .csv, .txt or .csv formats. Okay, these are the examples. They used to manage data in plain text. Let me write here, plain text. Data stored in plain text. Okay, that means it has no structure. Okay, and also hard to search and manage these kind of databases, right? It is also database. Initially they started with the flat file system. Okay, after that we have hierarchical and network databases came into the picture. In the 1970s, they came into the market. Okay, here data will be stored like a tree. That means parent-child relationship. Okay, I already explained that. Okay, IBM's IMS is a is an example for that. Okay, difficult to manage the relationships between data. Okay, in 1970s, we used to have hierarchical and network databases. Okay, and the major change in 1980s, if you see that one, relational databases came into the market. Relational databases. Okay, relational databases, they came into the market. Okay, here it's a big revolution. Okay, here data will be stored in tables. That means rows and columns. Data will be stored rows and columns format. Okay, it is our concern here. Relational database management system. Relational databases, SQL Server is the example for it. Okay, here examples are SQL Server, Oracle, okay, MySQL. Okay, these are the examples. Okay, and actually here we use SQL query language, structured query language, to get the or to operate on the databases. Okay, next one is Next one is in 2000, web technology came into the people started using web technologies, and big data, along with that big data came into the market, and no SQL. Okay, no SQL. Okay, they started using web technology, big data, no SQL. Actually, we get a huge amount of data from websites. Okay, so social media or applications. So to store that, we started using big data also. Big data also. Okay, so it can handle huge amount of data. Big data, in the sense, it can handle huge amount of data. Okay, it's a big revolution again. So here examples, MongoDB, same Cassandra, and we also have CouchDB. Okay, let me write here. Actually, it deals with huge data from websites. Okay, and social media posts, or social media or like applications, apps. Okay, now the next one is cloud databases. Okay, in 2010, cloud databases came into the market. Okay, that means here databases okay, move to cloud platforms. Cloud platforms. Okay, so no need to install locally. That means no need to install locally. Okay, here examples are Azure SQL. Okay, Amazon RDS are the examples. And in 2020, another big revolution, artificial intelligence. Okay, here real-time data, use real-time data, and multimodal databases came into the market. Multimodal databases. Okay, it supports actually machine learning. Okay, and real-time analytics. Okay, real-time analytics, and it can handle it handles structured plus unstructured. Okay, and also graph data. Okay, together. Okay, examples are Cosmos DB. Okay, and Snowflake, and Databricks also another example here. Okay, now the next one is what is the fourth one? Relational database management system. Okay, let us start that one. RDBMS. Okay, relational database management system. Relational database management system. Okay, what is RDBMS? Okay, actually it is a type of DBMS, database management system. Okay, that stores data in the form of tables. That means rows and columns. Okay, that means relation. Just see relation. The relation part means data in different tables, okay, is connected. That means related through, okay, through keys. Okay, later I will explain that primary keys, foreign keys and all. Okay, this is RDBMS, Relational Database Management System. Okay, and this relational database management system, this concept was introduced by Edgar Frank Codd. Okay, this concept was introduced by Edgar Frank Codd. Okay, EF Codd, we call him as EF Codd. Okay, he was an employee of IBM at that time. He was a scientist. Okay, actually he created 12 famous rules. 12 famous rules. We call them as Codd's rules. Okay, to define uh, uh, RDBMS. That means if any database, let me write a database that follows these 12 rules, okay, then that database becomes a perfect RDBMS. Okay, a database, or let me write any database that follows these 12 rules, then that database becomes a perfect relational database management system. Okay, actually we have 12 rules here. Okay, in another 15-20 minutes I will complete this. Okay, actually EF Codd rules we have, let me see here, let me copy. No need, you just see here. We have 12 rules here. Okay, just see the foundation rule and information rule. Okay, let me write here. The first rule is, let us see the first two rules. Okay, information rule. What it is? Information rule. Okay, what exactly the information rule says is all data should be stored in tables. This is the first one. This is the first rule. Okay, that means rows and columns. This is the first rule. All data should be stored in tables. Okay, let me copy this here. Here I have one customer table. Okay, I have one customer table. We have data is stored in tabular format anyhow. See, customer ID 10, 11, 12, customer name. Here the names are there. City, Mumbai, Delhi. So here city names are there. Okay. Now, what is this? The first rule is all data should be stored in tabular format. Tables. Here, table. Okay. Now, let us see. Here, data, if you see like this, okay, customer ID 10, Sachin, Mumbai. Okay, this is actually we have three records. We call them as records. Okay, now let me write here. Let me write here. We call them as rows or records. Okay, records. Three records are there. Na? Three rows or three records are tuples. Okay. Three tuples or three records or three rows. Okay. Three rows are there, three records are there, three tuples are there. And another one is, if you see city, customer name we have, okay, customer ID. What are these? These are called as columns. These are called as columns. Okay. Let me write here. These are called as columns. Columns are fields or attributes. We call them as attributes. Columns, fields are attributes. Okay. Here we have three records. 100 records are there. 100 records are there. 1 lakh records are there. Okay. Like that we can say, right? So these are called records. And these are the columns. City is a column. Customer name is a column. Customer ID is a column. Like that we speak, right? So these are the fields or columns or attributes, and these are the records. These are the records or rows. Okay. So actually, till now what we discussed is actually here table in the sense, finally table in the sense what? Table means what exactly? Collection of rows and columns, right? Collection of rows and columns. Okay. Now, what is a row? Row in the sense collection of field values. See, city is a field and its values are Mumbai, Delhi, Hyderabad. Customer name is a field or a column. Its values are Sachin, Rahul, Vijay. In the same way, collection of field values. Row in the sense collection of field values. Next, columns. Columns in the sense collection of values belongs to one field. Okay, one field. Collection of values belongs to one field. Column, this is the column. Okay, it's a collection of values. What are the values here? Mumbai, Delhi, Hyderabad. This belongs to one field. Here field is the column. Field is nothing but, here see, city is column, city is field, city is attribute. Okay, so collection of values belongs to one field or collection of values belongs to one column. Okay, now table, collection of rows and columns, columns. Now what is a database? Database nothing but collection of tables. Okay, that means database is a collection of tables. Table is a collection of rows and columns. Rows is a collection of field values. Columns are nothing but values belongs to one field. Okay. The next one, second rule. This is first rule. Second rule. Let us try to understand that. Rule 2. Guaranteed access rule. Guaranteed access rule. Okay. What it says is every table must contain primary key to identify the records uniquely. Okay. The second rule says every table must contain a primary key to identify the records uniquely. See here, 10, Sachin, Mumbai. It's a unique record. 11, Rahul, Delhi, unique record. In the same way, here what this rule says is every table must contain primary key to identify the records uniquely. Okay, let me copy one table here. This is the table. We have employee table. This is the table. Okay. Here we have 3 records. Here we have 3 records. 3 records. Okay. This is employee table. Suppose if we have 100 employees, that means 100 records will be there. 100 records will be there. Okay. See, there is a chance of having same name. Okay. There is a chance of having same name, same date of joining. See here, if you say this one, there is a chance of having same date of joining, or salary also. There is a chance of having same salary. Okay. Now, suppose if you want to update the information, on what condition, you will update the row or record. Okay. So for that we need an ID. Here, see, primary key. It is saying primary key to identify the records uniquely. We need an ID, and that ID we call it as a primary key. We call it as a primary key. Suppose here employee name, job title, salary is there. Now I can include employee ID right now. I can include employee ID. In companies, one employee given one ID only, one employee ID only. That employee ID company never give to another ID, another employee, right? So it is unique. So to identify the records, we can maintain employee ID as the unique key or primary key to identify the records uniquely. Okay, suppose employee ID here, I have employee ID, I have employee ID. Let me see employee ID. Here I have 101. Here I have 102. Here I have 103. So this is not repeated. 101. It's unique number. It's a unique number. With this number, I can uniquely identify this complete record. With this ID, I can uniquely identify this complete record. And in the same way, with this number, I can uniquely identify this record. That is called as a primary key, which is used to identify the records uniquely. Okay, in the companies or in banks also, if you take bank, account number is the primary key. If you take bank, okay, primary key is account number, right? Account number. If you see the government organizations, okay, primary key is what? Aadhaar number. Like that, election department voter ID, income tax department PAN number. Like that, we can take examples. Okay, even if you maintain serial number as a primary key, then serial number never be repeated. That means you can identify the record by using serial number also. Okay, that is also valid. Okay, no problem. Okay, next, what are the examples? I said account number. Okay, EMP ID, employee ID, Aadhaar number, we can take PAN number, okay, voter ID. Okay, so so like this second role, this is the second role. We can manage or we can identify the records by using primary key. This is the second rule. Okay, we have RDBMS features that we can see in the next class. Okay, this we can see in the next class. Okay, let me know if you have any doubts. Do you have any doubt? Jai Simha, you have any doubts? Today is the first demo.
Yes, no doubts to mine.
Okay, so we can continue this tomorrow. Okay.
Okay, thank you.
Fine. Okay.
Bye.
Good night.